Okay, so uh, you can see here the table, right? You can see the mode, the median, the mean, and the median again as the best measure of central tendency. And on the left column of this table, we have the type of variable because, as you know, there are different types of data. It's not only numerical data or so we'll see. For the first one, nominal data, the best measure of central tendency, and sometimes the only one, the unique one, is the mode. What is nominal data? Nominal data is basically data which does not represent any quantity. So it's basically not numerical data. For example, names, your names, the names of the class. Imagine I count, I want to calculate the mode of the names of the people in the class, yeah? And then I said, okay, I have five people, yeah? I have one person called Miguel, another person called Bruno, another person called Miguel again, another person called Beata, and another person called Johannes, yeah, for example. Imagine that we want to calculate the mean of these five values: Miguel, Bruno, Miguel, Beata, and Johannes. Yeah, we cannot calculate the mean because they don't represent any quantity. But can we calculate the mode? Yes, because we just need to count the number of repetitions for each element. So Miguel is twice, and the other three is one. So what is the mode of this dataset? Miguel, why? Because the type of data is nominal. We cannot calculate the median, we cannot calculate the mean. That's why the best measure of central tendency for nominal data is the mode. Ordinal data. Ordinal data is data which basically represent a rank, like in a race. The first one, the second one, the third one, the fourth one, and so on, so on, so on. In that case, the best measure is the median, okay? Is the median because these values, they don't represent quantities, they represent positions. So imagine, for example, we have a person who competes in a race 10 times, yeah? Or we have all the alumni, all the students from my class who participate into a race, and then we have the first position, the fifth position, the 10th position, the 99th position, 25th position, and the I don't know, a 10,000th position. So what is the central value which represents the 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 sample, this population, according to the performance in this race? If we calculate the mean, we have to calculate the mean between 1 and maybe 10,000, but there are outliers there. It's not a reality. The reality will be the median. So we calculate with the, okay, we have a first position who is, I don't know, Kyla, and the 10th position who is Johannes, the 15th position who is Beata, and the 20,000th position who is Natange. Yeah, and then we calculate the median, and the median is maybe this 15th. Yeah, or I don't know which the it will be the median, the mean between the second and the third I mentioned. So it will be something around 15. So it's more representative, yeah, because we have 4 students who participated in this race. One is very good because he won the race, and then another one who got 20,000. So it's not fair to to calculate the mean. We calculate just the median. Okay, you can think about that, but we'll have more examples later. And then we have another 2 types: the interval ratio and the interval ratio when it is not skewed, and interval ratio when the data is skewed. When it's not skewed, if it is numerical data, we always take the mean. When it is skewed, we'll take the median. Yeah. Why? Because skewed means they are outliers. The median represents better skewed populations. See, this is something we already demonstrated a couple of slides before, or 2 or 3 slides before, when we were defining mean and median. But now it's important to define another type of variables, what is called interval variable and ratio variable. What is an interval variable? If we just read the definition, it's a measurement where the difference between two values is meaningful. The difference between a temperature of 100 degrees and 90 degrees is the same as the difference between 90 and 80 degrees. So the difference is important, is what really matters. But the zero value still has a value. So if we can measure zero degrees is actually a measure which has a meaning by its own. Yeah. So these are the two characteristics of the interval variable. The difference is important and the zero value is still a quantity. But the ratio variable has all properties of interval variable, but also has a clear definition of zero. When the variable is equal to zero, there is none of that variable. So that means basically zero definition represents the origin. The origin. For example, in terms of distances, okay? When we measure a distance, zero distance means no distance. Or when we have a specific object, for example, apples, we can have one apple, two apples, three apples, 1,000 apples. But if we have zero apples, means we have nothing. Yeah. Okay. So this is basically for your interest. It's not really important right now because we are considering always interval variable. But if we talk about ratio variable, you should also know what are we talking about. Okay, so yeah, I think it's a good review of the type of variables. Remember nominal, ordinal, and then interval, skewed or not skewed. Okay, let me check the time. 7 minutes. So let me stop also this audio here and then we move into the next one.